Hey everybody, it's Mr. Carr again. Today, I'm just going to go over briefly how we can do our regression equations in Desmos. Okay, so I'm going to go over each of these very quickly. It all has to do with typing in a model of the function as we go through. So what I'm going to do is I'm going to create a table here. Okay, whoops, let's move this up here. You don't normally have to do this. When you just create the table, it should automatically be a X1 and Y1. Okay, so I'm going to do this in a way so that I can have that X1 and Y1 just like that right there. Okay, whatever your numbers are. So I'm going to go with a very basic one. Let's just go with like negative, we'll go -3, -2. If I establish a pattern for my X's, it'll continue the pattern for me. Kind of nice. I'm going to take this up to 3. What I'm going to do is I'm going to put in a quadratic just so we can see what this looks like. So for example, I'm going to do -3 squared is 9. -2 squared is 4. -1 squared is 1, 0, 1, 4, and 9. So if you look in the graph, you see how, make it a little bit easier to see, you see how it has a quadratic shape. So if you have any kind of shape that looks like this, where you have a quadratic, then you're able to go through a process that you can choose what you want to do. So for example, here's a quadratic regression. Okay, so quadratic regression here is y1 is approximately equal to ax1 squared plus bx1 plus c. Okay, when you type this in, so I'm going to actually just type it in right now just to practice that. I can type in y1. As soon as I do the one after, it'll make it it'll make it a subscript. And then you're going to use this symbol here. You can pull that up on the keyboard. Should be near the escape key, but it's basically, Desmos is going to read it as approximately equal to. So how close is it to this line? So with a quadratic, that is ax squared plus bx plus c. So I'm going to keep it as a, but when I do x now, I needed to look at the table up here. I want to refer to x1 because that's my table. So ax1, I'm going to do that squared plus bx1 plus c. That's my quadratic. If I graph this, you can see, yes, that quadratic goes through perfectly. Now, let's say I change some of these numbers around a little bit, so it's not a perfect quadratic. Maybe this is a 6, and this is a 1.7. This is a 3. This will be a 4 is fine, and this is a 12. Okay, we still get an overall quadratic shape because if I look at that one, you can see how it kind of dips down and comes back up. So I would still call that a quadratic. So we can still do this one here, and you get a line of best fit. It's close, but it's just not exact. Okay. If I have other values, if I just jump to some other ones, you might not see a quadratic very easily. And that's why we can kind of just look for it and see, does it have a curve to it? Does it have a kind of a exponential curve? What is the curve that it's creating with our scatter plot? If something looks pretty close to linear, like we can compare the two if I do something like this. Let's say I go, let's go with 5, 8, go 7, and we can go 12, 11, we'll go 15, whoops, too much, 15, I'll go, and then we'll go 20. So if you look at that graph, it doesn't really look, if I take off that quadratic, it looks more linear. So that's why I'll do a linear regression. So it looks like this. Again, we need to type in y1 and x1 as my variables, so it references the table, but I'm going to do it as basically slope-intercept form, mx plus b. But I'll keep it as a and b as my parameters. So it looks like this. Okay, so again, you're typing this in. You type in y1 approximately equal to a x1 plus b. Okay, so that's what happens with those. And it just depends on how you want to look at, like, what do you view the pattern as? Okay. Now, if you were to do some other ones, this is linear and quadratic. The rest of these are pretty much the same idea. You just need to be able to type it in. So a cubic, you're going to take x1 to the third power plus bx1 to the second power plus cx1 plus d. Now we're adding on to what the quadratic was. And here's what a cubic regression kind of looks like. Maybe there's a cubic pattern. It looks pretty decent there. Okay. So that's the cubic regression. The quartic regression, we're going to take it up to the fourth power. So ax to the fourth, ax1 to the fourth, bx1 to the third, cx1 to the second power, dx1 plus e. Again, with these exponents, make sure you're typing in x1 first so that it would look like this, or you type it in the order would be a x1, and then do your exponent to the fourth power. Okay, don't do that backwards. So that graph, it doesn't quite look like a quartic, but this is the line of best fit. This is what Desmos will come up with on that one. Okay, so again, you're going to view the scatter plots and say like, oh, it looks kind of close to that and doesn't like kind of look very close to it. You figure out what you think it looks the closest to before you do that. Exponential regression. So this is where your exponent, your x1 is up in the, is the exponent. So when you type, I'll go through that typing real quick there. You do y1 approximately equal to a multiplied by b raised to the x1. So again, you type 1 right after x, so it makes the subscript, and this will actually get refer back to this table up here. So always click log mode. Okay, do the log mode on that one, and then this will give us our parameters. Now let's take a look at that. Not bad. Okay, it's a pretty decent fit to that one as well. Again, if you think you see a curve to it, maybe it's an exponential. Okay, so this is me putting x in as my exponent, and then a and b are my parameters here. But again, click log mode. The last one was our power regression. Power regression looks like this, where basically my exponent is the factor up here is b. My x1 is what comes down here. Okay, so again, if I type this, I'm going to do a multiplied by x1 raised to the b power. Now this one, usually log mode popped up on here, but it doesn't look like it did in this case because it's not much of a curve on this one. Okay, y1 and x1 does not really have a power curve to it. So with the power regression, you might get something a little bit different. I'd have to pick up some different numbers. Let's see here. What if I start flattening that out? If I go to 15, go to 16, and we add some more numbers here. Let's go 4 goes to 17. Maybe it's 18 like that, or 17.5. Give me 1 second here. Okay, sorry about that. So for some reason, Desmos did not like my numbers that I chose for the original one. So I'm going to change it up and make these the values now. Okay, so in this case, now log mode does pop up. So I'm going to click that. So you notice my graph does not show it, but if you go up to your stat plot, you click this little zoom fit here. Now I can see it. And there's my power regression. So again, this is a times x1 raised to the b power. Here are my parameters a and b. So the idea is that any kind of regressions you do, you're looking for those parameters, whichever how many you have to deal with, depending on the type of function you're doing. But you want to get those written down for yourself so you can help model what's going on with the problem in that, or what's going on with that setup in that scatter plot. All right, and that's it for our regressions. Take care, everybody.